Want to update your firmware? Stick around, because that's what we're going to do today for the Cr-10S. Hey, welcome to the show. My name's Richard Cleveland. I'm your host here 3 times a week, every Monday, Wednesday, and Friday. And today what we're looking at is firmware. And today I'm going to walk you through the firmware. We're going to make some changes in that firmware. We're going to show you what programs we used. And we're upgrading the firmware for the CR10 today. Cr-10S to be more specific. It is the latest edition of the Cr10 to hit the marketplace, and there are a couple of little tweaks we should make. So we're going to walk through that right now, so stick with me as we head over to the computer and we start today's tutorial. Before we start today, let me just say that this that we're going to cover is for the Cr-10S and not for the Cr-10. So there's today's disclaimer. But we're going to use the Cr-10S as our demo to upgrading your firmware. So let's get started. Before we start, there's a couple of things that we need. We need to have the latest version of Marlin downloaded, and we talked about that on Monday. I'll link that in the card up at the top. And you are also going to need the Arduino IDE, which I am also going to link up in the card or in the description down below as well, that you'll be able to find. Now, certainly you can go and download hex files for the Cr10, but what I want to illustrate today is that we are going to make this firmware our own, and we're going to give it some features. So what we want to do first and foremost is open up our Marlin 1.1.x folder. We're going to double click the Marlin 1.1.x. We are now going to double click on the Marlin folder, and we're going to scroll down till we see Marlin INO .ino. So we'll double click that. It will open up our Arduino software. Once that is open, we are going in and we're going to start changing a few things. So we've got the Marlin firmware open now. We can see we're using Arduino 1.8.5. We have our line numbers down the side, and we've got fairly big text. I increased the text prior to this so that it would be easier for you guys to see on screen. Now, along the top, you'll see a whole bunch of tabs. The tab that we're interested in today are the configuration.H tab, which is right here, and the configuration_advanced tab. We're going to start with the configuration.H tab first. As I said on Monday, go through and read through this file first and foremost before you start changing anything. And now that you've done that, and I'm going to assume that you have done that, we are going to scroll down to past the getting started, and we're going to scroll down to the baud rate. Now, these settings determine the communication speed of the printer. So 250,000 works in most cases, but you might try to lower the speed if you commonly experience dropouts during host printing. You may try up to 1 million, but you don't really need to go that high because most boards aren't going to be able to sustain that high of file transfer rate. Okay, so first and foremost, we are going to go down to define baud rate. We want to make sure that this is uncommented, which means you see these two little dash line or slash lines. That means that is commented out. And all of the things that have these two little lines means that it won't be read by the software while it's performing its operations. So first and foremost, let's define our baud rate. We're going to actually lower the speed. It's not that noticeable, but we're going to lower it to a speed that we know works very well with 90% of the boards that are out there today. So what our speed is going to be is 115,200. That is going to be the speed in which we are transferring data from our computer to our 3D printer's control board. We're not going to define Bluetooth because we don't need to. Now, the following selects which electronics board you have. So make sure that you know which one you have. In the case of the Cr-10S, it is a Ramps 1.4 EFB board. So it's pretty standard among 3D printers. So what we're going to do is we're just going to leave that the way that it is. Now we're going to go down to optional custom name for your rep strap or other custom machine displayed in the LCD ready message. So what we're going to do is we're going to uncomment line 127 by taking out the 2 slashes. Now that line will be read as part of the startup sequence. And we're going to change 3D printer. You want to leave the quotations on either end of what you're typing in here. And we're just going to call this Creality CR-10S. Okay, and that's what's going to come up in the display when we fire up the printer. Now, the next area that we're concerned about deals with the temperature sensor. So we're going to scroll down, and it's a good practice to always save your work after you change something. So right now we changed line 127. I'm going to save the work, and that little squiggly S with the line through it is gone now up in our configuration.H. So we are going to move down to our temperature sensor area, which is right in the thermal settings here. And we are going to go down to line 289. And this type of sensor used for measuring the hot end temperature for the stock hot end, you'll use number 1 unless you've changed out that hot end and you have moved to a E3D V6. For most cases, you're going to leave it at 1. But if you had an E3D, you would change that number 1 to a number 5, okay? Now, the max bed temperature, we are going to set to 5 because that is what the stock firmware tells us to do or is instructing us to do. Now, the next area we want to go to, and that's, again, that sets the stock bed temperature, is we're going to go down to line 328. And that's still within our temperature area here. And what this is doing here in this area, when your temperature exceeds the max temp, your heater will be switched off, okay? This feature exists to protect your hot end from overheating accidentally and not from thermistor short failure. You should use min temp for the thermistor short failure protection. So what we're going to do here is we're going to look at this line 328 and we are going to find heater 0 max temp. Right now it's set to 275 degrees. That's a little too hot for the stock hot end because it has a PTFE liner in it. So we are going to change this down to 250. So now it will only heat up to a maximum of 250 degrees. And we're going to scroll down to line 133 here, where it says define bed max temp. And we are going to change that to 120 degrees. It is set in the Marlin firmware at 150, but I have never come across a bed temperature that will hit that. That's quite hot, so I would just change it to 120 and always be on the safe side. Now we're going to scroll down to line 532, and 532 is going to be in our movement settings area, as you can see here. So we're just going to go down to line 532, and this is the default steps per unit, and that is steps per millimeter You can override this with an M92 command, but we're not going to get into that because it's a little bit more beyond the scope of what we're trying to teach today. So the line that we want to change here is 532, and we're going to set our steps per millimeter a little different. We're going to leave the X and the Y steps at 80, but we are going to change the Z to 400 instead of 4,000. And we're going to change the extruder to 95. And these are the values that are set by Creality for this for the Cr-10S. Now, we're going to move down a little bit more to the default max feed rate. And just before I do that, I want to say that this is the amount of steps right here in our default axis steps per unit that your printer has to use to move a specific distance. Things like drivers, motors, gearing, screws can change these numbers, but the ones above are good for the stock Cr-10S. These can be tuned later from the control screen thanks to the EEPROM settings we'll be enabling a little bit later on. So right now, let's go down to line 535. 539 is the line that we want, which is the default max feed rate. We are actually going to change this because this is your max feed rate per second. So we're going to change this on the X to 2500. We're going to change the Y to 2500. And we are going to change the Z to 100. And we will leave our extruder at 25. Now, this is the fastest the machine will move in all directions, okay? So next line we want to go to is 557, and that is our default acceleration, and that is right here, default acceleration. Our default acceleration, we are going to set to 1,000, okay? So we'll just highlight that, and we'll just go 1,000. Now, what this does for us is this is the acceleration applied to your extruder retraction. You want this as high as it can go before the filament starts stripping out to help prevent clogging and stringing, okay? The next line we want to go to is, oh, pardon me, this, I'm reading the wrong area. Can you believe it? Define your default acceleration should be set to 575. That makes more sense. Acceleration is the rate of change of speed. It is defined by millimeters per second squared, okay? Your printer slows down when changing direction and then speeds back up again in straight lines. This line is the acceleration the printer will make during printing moves. 575 is fairly slow, but for a printer like the Cr-10S with a big moving bed, it will help to prevent ringing in your prints. Now we'll go on and change that retraction setting. I was reading the wrong line before, excuse me. So define default retraction acceleration, which is line 558. We are going to change that to 1,000. And this is your acceleration for retraction and preventing. This helps with preventing that stringing. Now, 559, we are also going to set to 1,000. And the reason that we want to do that is this is the acceleration of your printer when it's not printing. Since it's not printing at the time, it can be a little higher since you won't be able to see the ringing. If it is too high, you could see skip steps and layer shifts, and we've all experienced that if we've done a 3D printer upgrade. So now what we want to do is we want to move down to line 745. So we're going to just look for 745 by scrolling down. And this is a fairly long tutorial today, so stick with me. pardon me, 751 is the line that we want to go to. So line 751, this is invert the stepper direction, change or reverse the motor connector if an axis goes the wrong way. But we can change it in software, so that's what we're going to do. So on line 751, which is invert X direction, we're going to leave that as false. On 752, we are going to change that to false as well. And in invert the Z direction, we are going to say true. Finish spelling true. There we go. So now these three lines define the direction of each axis. If your machine moves in the opposite direction or what you expect, then change it to true or false. And that's really what we've done here. All right, so now we are going to move down to line 783. And 783 is defining our bed size. Now on the Cr-10S, this bed size on the X is 300 millimeters, and on the Y, it is 300 millimeters. So we want to make sure that we've changed both of those. So now we're going to slide down to define our Z max position, which is down here on line 792. And we know that the Cr-10 can print much higher than 200 millimeters in the Z direction. So we are going to put in 400, which is the amount of height in millimeters that it can print. Okay, so this is where we set all the actual bed sizes for the printer and the Z height. So we've got that done now. Let's go up and save the changes once again so we don't lose them. And now we are going to be moving on to line 827, which is define the filament runout sensor. If you don't have a filament runout sensor, leave this commented out. But if you do have a filament sensor, which the Cr-10S does have, we want to uncomment that so that it reads that as instructions. Now we're going to go to line 986. And line 986, what we're doing here is we're setting this to 3, which means it'll have to level 3 times along the X-axis and 3 times along the Y-axis for a total of 9 points. If you set this to 5, then it would mean you have to adjust level 25 times on the bed. 3 is a really good number for this. So we're going to make sure that our line here at 986 grid max points are 3. Don't use more than 7 points. 3 is more than enough for what we're going to do. And we're right now in the bed mesh bed leveling. Actually, I skipped a few steps. Let's go back up to 829. Where we did that. Actually, the number we need is 876. I'm sorry. 876, we want to define mesh bed leveling. Now, whether you have a sensor or not on your 3D printer does not matter with mesh bed leveling because it will come down and hit that end stop every time. So we're going to uncomment that. Okay. And where I'm getting this information is from printedsolid.com, and I'm going to leave a link for this entire tutorial in the links below, so make sure that you check that out. So now that we've got our points set, we've got mesh bed leveling set, we are now going into defining our LCD bed leveling, and that is at line 997. And that is right here, 997, define LCD bed leveling. What this does is this adds the option to run mesh bed leveling on the LCD screen, so you can see it right there. Gives you an option. So we're going to do that. We're going to uncomment that. We're going to go to 1005 actually, yes, 1005 in this case. And we want to uncomment define level bed corners. And that's what this is. So we're going to take out that and we're going to define that so it's red. Now we're going to go to line 1116. We're done here for now. Now we want to go all the way down to 1116 where it says define EEPROM settings. This allows you to adjust things like offsets and steps right from and store them right from the LCD. So we're going to uncomment that. We'll delete. So now it will do what we want it to do. And then we're going to go down to line 117 where it says define disable M503. Now the reason that we're doing this is a command that shows the settings as they were set in the firmware and not the ones you changed in the EEPROM. We're disabling this to save time and some memory. So we're going to disable that as well by highlighting it and getting rid of it. And now we're going to move on down the line to 1148, which is talking about our temperatures. Now, these are the temperatures of the PLA and ABS. There's two that are predefined in here for preheat constraints. We're going to change the 180. The first one here really refers to PLA because it's a much lower temperature. So we're going to up that to 205. We're going to change the bed from 70 to 60. And we're still going to leave the fan off because we don't need the fan on. And in the next case, which is ABS, we're going to change that to 250. Remember, our bed will only go as high as 250. We are going to change this to 80. And it's just preheating, so things get better. Now, these lines set the temps for the fan speeds, for the menu items, the ones that we left 0, to preheat PLA and ABS. Now, we're going to jump down to line number 1330. And we'll just scroll right down to 1330. And we see on line 1330 that there is nothing there. Actually, what we're looking for is on line 1332, defines SD support. We want to uncomment that because we have an SD card slot on that board. And this will enable that slot so that we can print from the SD card. And now we are going down to the encoder settings, which should be right around. They've changed where everything is here. 1357. We want to uncomment define encoder pulse per step 1. So we're going to uncomment this, and that's line 1357. And we're also going to uncomment 1363, which defines the steps per menu item, which is 5 in this case. And we're going to leave those two exactly where they are. This is how far the knob needs to turn to move between menu items. Make this number lower if it's too sensitive and higher if it's not. Okay, that's what you want to do here. So now we are going to look for the speaker, and that should be on line 1403, define speaker. We are going to uncomment that. This will let the machine beep and make sounds. It can be a little distracting, but it also can be a warning for you. All right, so now we want to find the controller, and in our case, we're looking for the RepRap Discount Full Graphics Smart Controller. And as we look through here, we have that down on line 1484. Define RepRap Discount Full Graphics Smart Controller. That is the controller that is inside the box on your Cr-10S. And we are going to uncomment that as well. Now we're going to go down a little bit further because we want to define the type of filament that we're using on this particular printer. And we want to make sure that, oh, this is, where am I here? Oh, yes. Okay, we have to actually go back up. I don't know why it made us go all the way to the bottom. We're going to go back up to line 140. This should have been done earlier, actually. See in line 40 where it says define default nominal filament diameter, we're going to change this to 1.75 because that's the diameter of filament that the Cr-10S uses. Now that we've done that, we've got all of our configuration. You see this double S? We haven't saved this configuration, so we're going to save that right now. Now we're going to go into configuration.H because there's a couple things we need to do in here. We're going to go down to line 658. I'll just scroll down to line 658. And what this is going to do is it's going to define baby stepping. And what baby stepping is allows you to adjust the Z-axis while printing to help get the perfect first layer. And this is something we're always looking for, is that perfect first layer. So 658 is the line that we're looking for. And there it is right there. So we are going to uncomment that out. Now we have baby stepping enabled. We're going to go to line 606 now, or pardon me, 662 now, which says define baby stepping multiplicator. Right now it's set to 1. We're going to set that to 5, and I'm going to tell you why. This is how much your Z-axis will move per rotation on the knob. I find 5 is a good number. But if you want finer control, then lower this number. If you want it to move more per click, then increase this number. But 5 seems to be right around that perfect nominal. So let's go to line 664 now, where it says define double click for Z baby stepping. We are going to uncomment that. And what that's going to do, what that does for us as users, is this makes it so if you want to adjust baby stepping, then you can press the control knob 2 times quickly and you'll enter the baby stepping mode, which is something that we definitely want to have on our 3D printers. And we can do this on any printer. Now, I know I'm doing this for the Cr-10S just because we had some requests about it. But this applies really to every printer out there. Some of the things are going to change, such as the size and your steps per millimeter. But for the most part, everything else is pretty much the same. So we've defined double click for stepping. Now we're going to go down to line 733. And line 733 says define arc support. What we want to do is we want to comment this out. We don't need it. And what this does is it's not really used since most slicers don't do this function by default. If you disable it, then we save even more memory on the board. The boards don't have a whole lot of memory on them. So now let's go down to 878 is our next stop on our tour. 878 is right there. And what we're looking for here is to uncomment define advanced pause feature. And of course, it's not right there. It's actually 879 because we're using the latest build of Marlin. So we are going to uncomment that. And what this does, this is for the filament runout sensor. It'll home the hot end and unload the filament from the nozzle. Then once you load more filament, it'll wait till it's extruded before beginning the print. So this is something that we want to make sure that happens if we happen to run out of filament. So if you're away and you run out of filament, it's going to home, and then you end up with less ruined prints at the end of the day. Now, one last thing we're going to do, because this is the CR10, is we're going to go into our pins_ramps.h file. And we are just going to go and find that pins, and I'll show you exactly how to find that in just a second. Pin_ramps.h. All right, so now we're here. We want to go down to line 255. And we have to change one pin on here, and that is it. So let's go to define pin out or run out pin. Right now it's set to 4. We're going to set that to 2 because that's the way that the board works. We're changing this one value from 4 to 2 so that we're using the right pin for the filament sensor. And that's really all we have to do here. Now we want to save this, and our firmware now is completely set up to be uploaded to our 3D printer, the Cr-10S in this case. And we are now going to stop today's tutorial, and on Friday we're going to pick up where we left off, and we're actually going to upload this new firmware to our Cr-10. Well, I hope you enjoyed that and got some information about how to do upgrades in your firmware, regardless of whether you're doing it for the Cr-10S or you're doing it for another printer down the road. The basics of what we covered today in the firmware are pretty much the same all across the board, regardless of what printer you're using. Now, there is a caveat to that. You can't use that upgrade on let's say DLP or SLA printers, but for most Cartesian-based machines, it should be fine. Hey, listen, I want to thank all of my Patreons for the help that they have given to the show. Your support helps us to bring you brand new material each and every week. And if you're not interested in being a Patreon, that's okay too. If you'd like to, you can buy me a coffee at the link below. And I also want to thank our sponsor who gives us this lovely space to use each and every week, and that is spool3d.ca. Print it right, print it with spool3d.ca. They have everything you need from printers, parts and accessories, and filament. And if you're in Canada with orders over $140, your shipping's free. So with that being said, you guys have yourselves a great day. Check out all the links for today's show down below in the description. And we'll see you again on Friday when we upload this new firmware to the Cr-10S and take a look at some of the changes that we made. Till then, have yourselves a great day.